If you then go a little bit more broad in the radar world and look at other radar systems, tracking radars, surveillance radars, proximity radars, you can take the same advantages that you had with building radar altimeters and apply it to that space. So what do those radar designers care about? We're talking about much longer distances, tens of kilometers instead of just a few kilometers, and usually more interested in the shape and size and movement of the target. The radar altimeter space, the ground is well understood, right? The nature of that target is very easy to understand. But in the radar world, where you're trying to detect a target, and the target could be quite small, it could be shaped in a way that minimizes its radar cross-section so that it's hard to detect. So those engineers that are involved in that work are really spending a lot of time trying to improve resolution, to be able to see targets in the presence of things like clutter and multipath signals reflecting off of surfaces and buildings and other targets. So all of these things make resolution very important to those guys. So how do we fix those problems? Well, of course, the biggest one is distance. So for us, distance means more fiber. We build systems that can easily work out to tens and even hundreds of kilometers, and then at the same time provide good resolution at those distances. So a system that operates at 100 kilometers with tenth or hundredth of a kilometer resolution is quite easy with this sort of approach. The other advantage in that space is dynamic range, right? You have a very distant target with a very small cross-section. That means that the reflected signal is attenuated a great deal. It's very, very small compared to the radiated signal. So how does our system address that? We take an analog approach to this problem. And analog sounds old-fashioned, but it has some distinct advantages, one of which is dynamic range. 110 dB, 120 dB is easily achievable with an analog system. A digital system that samples the signal and delays it and reproduces it, they're going to be limited by of course, the number of bits that they use to get the resolution that they want. So they worry about accurate reproduction of the signal once it's been transmitted and detected, converted from analog to digital, and then back. All of that degrades the original signal. So you worry about when I make this measurement using this digital device, am I measuring my system performance? Am I measuring the degradation from the device that's being used to measure? Has the same advantages though with the altimeter in that it's signal agnostic. It doesn't care what that signal looks like. Also, in many pulsed applications, those are very frequency rich. Very narrow pulses produce wide band signals. So if you're using an analog optical approach, instantaneous bandwidth is tens of gigahertz, right? It's very wide band, so it responds very rapidly. So pulsed systems are actually, it's a benefit to use an analog approach like this because of that instantaneous bandwidth. So that's the second large area that we service with this type of equipment. I should mention that all of these are physically small for laboratory-based equipment. A 2 or 3U 19-inch chassis is pretty common size for most of our applications in the radar space. Literally hundreds of kilometers can be replicated in that kind of space, and a 3U chassis could be as light as 35 pounds. So it's very very lightweight, very small size, and surprisingly rugged. Optical fiber seems, in some sense fragile because it's glass, but it's also extremely low mass. So lightweight, low mass means that you get, it's hard to damage it. Our failure rate is actually very, very low, and repeatability is very high because it's a physical replication of the channel. So every time you turn it on, it's the same. It does not degrade over time and resists physical damage. So it's an ideal sort of a piece of test equipment. Doesn't require elaborate calibration. We do recommend a verification, periodic verification, annual or biannual, to make sure that nothing has been damaged. But in terms of actual calibration, it's really not required for this kind of test system approach.